Wavelength of ultraviolet from 60 nanometer to 400 nanometer. Its frequency is from 10 to 15 to 10 to 17 Hertz. The energy level from 10 to up to 124 electron volt. And on the EM spectrum is light between X-ray and visible light.
In 1801, he was experimenting with silver chloride. Ritter decided to measure the rate at which silver chloride reacted when exposed to different colors of light. To do this, he directed sunlight through a glass prism to create spectrum. Ritter noticed that the silver chloride showed little change in the red part of the spectrum, but increasingly darkened toward the violet end of the spectrum. This proved that exposure to blue light did cause silver chloride to turn black, much more efficiently than exposure to red.
Through his measurement, he saw that the silver chloride displayed an intense region well beyond the violet end of the spectrum, where no visible light could be seen. This new type of light, which researchers called as chemical rays, later became known as ultraviolet light or ultraviolet radiation. Research experiment, along with Herschel's discovery, proved that the invisible form of light exists beyond both ends of the visible spectrum.
Remember, the shorter wavelength, the higher energy per proton, and thus the more dangerous the radiation. UVA is less dangerous than UVB, which is less dangerous than UVC. The shorter wavelength of ultraviolet light, VUV vacuum UV and EUV extreme UV, are the even more dangerous, but luckily they absorb by air and only pose a hazard during close exposure to short circuit at an electric arc welder.
Ultraviolet A or UVA or long-wave UVA light is commonly known as black light, and most people are familiar with its effects of making white clothing glow in the dark. UVA spans the wavelengths from 400 nanometers down to 315 nanometers.
Ultraviolet B or UVB or medium wave UV is the wavelength between 315 nanometer and 280 nanometer. These wavelengths are responsible for much sunburn and skin cancer, as well as the highly beneficial effects of vitamin D, which the skin naturally produces in hue radiations during exposure to UVB.
Ultraviolet C, also called UVC or shortwave UV light, spans a wavelength range from 280 nm down to 100 nm. Although wavelengths below 200 nm are strongly absorbed by the oxygen in air.
Scientists learn about the makeup and energy levels of atoms by studying UV rays. Experts also learn about distant stars and galaxies by analyzing the UV rays that are giving off. Artificial sources of UV light are often used to stimulate the effects of solar ultraviolet radiation in the study of deterioration of materials on exposure to sunlight. Scientists learn about the makeup and energy levels of atoms by studying UV rays. Experts also learn about distant stars and galaxies by analyzing the UV rays that are giving off. Artificial sources of UV light are often used to stimulate the effects of solar ultraviolet radiation in the study of deterioration of materials on exposure to sunlight.
UV rays are necessary for our body to produce vitamin D, a substance that helps strengthen bones and safeguards against disease such as rickets. Vitamin D lowers the risk of getting some kind of internal cancer like colon cancer.
They also a very fun fact that experiments indicate that the bee, bird, and the butterfly and other insects can see ultraviolet light. The reflection of the UV rays of the wing help insects identify mate.